GATE 2024 question 53. Consider the function this, and we have to find out the directional derivative of this function at the point P along a direction. Okay, directional derivative by definition is given right here, where this is my directional derivative, this is the magnitude of this vector, and this is the vector, which is this one right here, and which is the grad of f, which is right one here. Now, we'll see how grad f is calculated, but let us try to understand what is really meant by this direction derivative. Let us say you are going up a hill, something like this, which is your given by this function right here, and you are trekking from here. So you are not you are trekking something like this. You are something like this. That's your trekking path. So at that point P, where you, let's say at any particular point you're standing, the grad f, which is given by this, gives the steepest uphill direction, which gives you the steepest uphill direction here. Okay, that's your grad f. And this is the direction. Let's say you are this is the direction, that's a. So what is the slope? What is the slope in the direction you are moving? You are not really moving in the steepest direction. You are moving along this direction. So what is the slope along the direction you are trekking? So that is the value of this one, and this direction is your a vector here. So this is my a vector here. Okay, so let us try to see an example. So let's say a fluid is flowing, through a tube here. So these are my streamlines. At any particular point, point, let's say this is my delta F. So F, of course, stands for this is a temperature function. So if goes along this one, we know. So this is the steepest gradient along at this particular point. Steepest gradient along of temperature, gradient of temperature at this particular point. And we know Q is equal to negative of K at this grad T. So heat transfer definitely happens in this particular direction only. But let's say the fluid is moving along this direction at this particular point. So this is my A vector, and you want to know what is the rate of change of temperature along this direction. In this direction, the heat is flowing, okay? But you want to know how much this fluid is experiencing the rate of change of temperature. Then you really find out this directional derivative. So this is my, you find out the direction derivative. You take the dot product of this grad, and you take grad and the unit vector. So this is my unit vector. So you take the dot product of the unit vector and the grad f at this particular point, and this gives you what is the rate of change of temperature experienced by a fluid packet as it moves along in this direction at that particular to our actual problem. So this is the function which is given. Let's say that's my temperature field, and you find out the grad f, where you take the partial derivative with respect to x, y, and z. And remember, this is a vector. Okay, this of course is a vector, and this of course is a vector, but this is a scalar quantity. That means because this is a slope, this is a value. Okay, so we find out grad f as this one. So this is very easy to find, and this is my the vector along which direction we have to find out the derivative. We find out the magnitude of this vector this way, and we take the dot product between the two, and the details are shown in this particular website.